The solar system is often imagined as a closed neighborhood, a place where planets, moons, asteroids, and comets all form together around our sun and have remained gravitationally bound to it ever since. In reality, however, it is not completely isolated. On extremely rare occasions, objects born around other stars wander into our region of space, briefly passing through before continuing their journeys across the galaxy. These visitors are known as interstellar objects, and despite the countless millions of bodies orbiting the Sun, only 3 such outsiders have ever been definitively identified. Each discovery has fundamentally reshaped how scientists think about planetary systems beyond our own, and has provided a tantalizing glimpse of material that originated light years away. The most recently identified interstellar object is known as 3I/Atlas, officially designated C/2025 N1 Atlas, and previously catalogued under the provisional name A11PL3Z. It was first detected in July 2025 by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, using a telescope station located in Chile. Although the name of the survey system might sound ominous, its purpose is primarily early detection and tracking of near-Earth objects, and in this case, there was never any danger to our planet. From the moment astronomers calculated its trajectory, it was clear that 3I/Atlas would not collide with Earth or any other planet. Instead, it is simply passing through the solar system on a hyperbolic path, moving too fast to be captured by the Sun's gravity, and will eventually disappear back into interstellar space. What makes 3I/Atlas especially fascinating is not just its origin, but what it can tell us about the formation and evolution of planetary systems around other stars. The discovery and analysis of this object were led by Dr. Bryce Bolin, a research scientist at Eureka Scientific Incorporated. Bolin occupies a unique place in modern astronomy, as he is one of the very few scientists in the world who has studied all 3 known interstellar objects. His work spans from 1I/Oumuamua, discovered in October 2017, to 2I/Borisov, identified in August 2019, and now to 3I/Atlas. In August 2025, he discussed the latest discovery with planetary radio host Sarah Al-Ahmed, sharing insights into how these fleeting visitors help scientists probe environments far beyond the reach of spacecraft. Interstellar objects are extraordinarily valuable because they represent one of the only direct ways to study physical material from other planetary systems without leaving our own. Telescopes can observe distant disks of dust and gas around young stars, and they can analyze the atmospheres of exoplanets, but those observations are indirect and limited by distance. Interstellar objects, by contrast, come to us. They allow astronomers to analyze their brightness, composition, activity, and motion at close range, using the same tools employed to study comets and asteroids native to our solar system. This opportunity is exceedingly rare, which is why each discovery sparks such intense excitement within the scientific community and the public alike. The first known interstellar object, 1I/Oumuamua, was particularly surprising and controversial. When it was discovered in 2017, it did not behave exactly like any asteroid or comet previously observed. It showed no obvious coma or tail, which initially led many scientists to classify it as asteroid-like. Yet its trajectory revealed something puzzling. It experienced non-gravitational acceleration, meaning its motion could not be explained by gravity alone. This kind of behavior is typically associated with comets, which emit jets of gas and dust as they heat up near the Sun. These emissions act like tiny thrusters, subtly altering the object's path through space. In Oumuamua's case, the acceleration was real, but the usual signs of cometary activity were strangely absent. Over time, the consensus shifted toward the idea that Oumuamua was indeed a comet, albeit a very unusual one. One leading explanation suggests that it may have been releasing gases, such as hydrogen, that are difficult to detect with standard observational techniques. This interpretation brought a sense of relief to many astronomers because it aligned Oumuamua with broader expectations about what kinds of objects should be most common in interstellar space. From both theoretical models and observations of our own solar system, Scientists believe that comets vastly outnumber asteroids, particularly in the outer regions where icy bodies are more likely to be ejected by gravitational interactions with giant planets. Those expectations were reinforced by the discovery of the second interstellar object, 2I/Borisov, in 2019. Unlike Oumuamua, Borisov was unmistakably a comet from the moment it was observed. It displayed a classic coma and tail, produced by the sublimation of ices as it approached the Sun. Spectroscopic studies revealed that its composition was broadly similar to that of solar system comets, though with some notable differences in the relative abundances of certain molecules. This combination of familiarity and difference was crucial, as it suggested that while the basic processes of planet formation may be universal, the details can vary significantly from one star system to another. Now, with 3I/Atlas, the pattern continues. Observations indicate that it too is a comet, showing clear signs of activity driven by the release of volatile materials. This consistency is important. If all known interstellar objects are comet-like, it strengthens the idea that icy bodies are the most likely to be ejected into interstellar space during the chaotic early stages of planetary system formation. As giant planets migrate and interact gravitationally with smaller bodies, many comets are flung outward at high speeds, escaping their parent stars entirely. Over billions of years, these exiles populate the vast spaces between stars, occasionally passing through systems like ours. Studying these objects also highlights the gap between theoretical predictions and actual observations. Astronomers have long debated how many interstellar objects should exist in the galaxy and how frequently they should pass through the solar system. Early models suggested that such encounters might be extremely rare, perhaps occurring only once every few decades or centuries. The discoveries of Oumuamua, Borisov, and now 3I/Atlas within less than a decade suggest that interstellar visitors may be more common than previously thought, and that improved survey technology is finally making them detectable. Modern sky surveys like Atlas play a critical role in this progress. By repeatedly scanning large portions of the sky and automatically flagging objects with unusual motions, these systems can quickly identify candidates for follow-up observations. In the case of 3I/Atlas, rapid international collaboration allowed astronomers to confirm its interstellar origin and begin studying its properties while it was still bright enough to observe. Timing is everything with such objects, because they move quickly and fade as they recede from the Sun. Beyond their scientific value, interstellar objects capture the imagination in a profound way. They are literal messengers from other stars, carrying within them the history of distant planetary systems. Each one is a reminder that our solar system is part of a much larger dynamic galaxy, where material is constantly being exchanged on cosmic timescales. Holding that perspective can be both humbling and exhilarating. These objects challenge us to think beyond the familiar and to recognize that the processes shaping our own planetary neighborhood are likely playing out countless times elsewhere in the universe. As astronomers continue to refine their instruments and expand their surveys, it is likely that more interstellar objects will be discovered in the coming years. Each new detection will add another piece to the puzzle, helping scientists understand not only where these objects come from, but also what they reveal about the diversity and commonality of planetary systems throughout the galaxy. For now, 3I/Atlas stands as the latest chapter in an unfolding story, one that bridges the vast distances between stars and brings a small fragment of the wider universe briefly into our reach.